Section 6.3, change of bases. So the first questions on this one, consider the following. So we have x equal 4, 0, -4, and the base b with 3 vectors, and the base c with 3 vectors in R3. Find the coordinate vectors x sub b. So the coordinate vectors x sub b equal C1 with the first vector, because we're going to work with the base b, and C2, C3 with the third column, and here's equal x. And then we're going to find C1 equal 4, because C1 and 0, 0 equal 4. And C2 is going to be equal 0, and C3 is going to be equal -4. That means x sub the coordinate x with respect to the b is going to be 4, 0, -4. X sub c, we're going to do the same thing with the base c. So C1, 1, 1, 1, and C2, here is the second column, and C3, here is the third column, equal x. Then C1 is going to be equal 4, C2 plus C1 plus C2 equals 0, and C1 plus C2 plus C3 equal -4. Now let's solve this system. C1 equal 4, plug in C1 here, C2 is going to be -4, and I plug in C1 and C2 to get C3 equal -4. That means x, the coordinate x with the base b is going to be 4, -4, and -4. This is the first part of this equations. Now the second part, I just plug in these answers. The second part of this questions is find the change of base from b to c. Be careful here, it says from b to c. So let's check the second part. So the change of base from b to c, that's how we're gonna read it, is going to be c, the first, you're gonna write down the base c, and then you're gonna write down the base b. So here's the base c, and here's the base b. By reduction, you're gonna reduce, or by using reduce row echelon form, you're gonna get this is the new matrix, 1, 0. Always this matrix is going to be, this side is the identity matrix. So this one's going to be the identity matrix, and the new matrix is going to be the change of base from B to C, which is 1, 0, 0, -1, 1, 0, 0, -1, and 1. So the change of base from B to C is going to be 1, 0, and 0. And the second part is going to be -1, and here is 1, 0. The third row is going to be 0, -1, and 1. Let's move on. Use the answer of part B to write down the coordinate vector with the base C. We already have the coordinate vector with the base C, which is 4, -4, and -4. We already have it, 4, -4, and -4. Now let's find the change of base from C to B. From C to B. So the change of base from C to B, always the first base is going to be the first one. And the second, from B to C, you're gonna write down C here. So write down the base B and write down the base C. By reduction, you see this matrix is going to be the identity matrix. And here is the new matrix is going to be the change of base from C to B. So it's gonna be 1, 0, 0, 1, 1, 0, 1, 1, 1. So we're gonna plug in here 1, 0, 0. And the second one is going to be 1, 1, 0, 1, 1, 1. The last part, they ask you to write down the coordinate vector with the base b. It's going to be 4, 0, -4. We already found that on the first option. So 4, 0, and -4. That's it for this question. So we got it right. Now let's keep going to the second one. Example 2, we're going to ask you exactly the same thing, but now we have polynomials. P of x equals 7 plus 9x, the base b equal 1 plus x, 1 minus x, and the base c is 8x and 10x. So let's check here. The first thing they ask you, find P of x, the coordinate vector P of x to the base b, and the coordinate vector P of x with the base c. Before that, sometimes you're going to get confused here. You can write down the base b as 1, 1, and -1, 1, -1. And you can write down the base c equal the base c 8x. The first is the constant. So the constant here is 0, then here is 8. And then here's the number, and here is the number with the x, which is 0. You can write down the base like this. So let's do the same thing. So P of x with the base b is going to be C1, you can times 1, and C2 times 1 equal 7. I write down here as a polynomial. You can use the bases, it's fine. Both is going to be right. So we get C1 plus C2 equals 7, and C1 minus C2 equal 9. By elimination, we get 2, C1 equals 16, C1 equal 8. Plugging in one of these equations, we get C2 equal -1. That means the coordinate vector P of x with the base b is going to be 8, -1. Now the coordinate vector with the base c is going to be C1, 8x, C2, 10 equal P of x. You can use this base instead of what you're doing here. That means you can say C1, this one equal the base. It's going to be easier. C1 and C2. So now we got 10 C2 equals 7, C2 equals 10 over 7 over 10, and 8 C1 equal 9. That means C1 is going to be 9 over 8. So the coordinate vector P of x with the base C is going to be 9 over 8 and 10 and 7 over 10. So that's what we're going to type here. We're going to type 9 over 8 here. This is 8, -1. And the second one is going to be 9 over 8 and 7 over 10. 7 over 10. This is the first part. The second part, we need to find the change of base from B to C. How are we going to read it? Be careful, from B to C. That's mean like this. From B to C. But always you're going to write down the C, then you're going to write down the base B. That's how we're going to write down before you're doing the reduction. So here's the second part. To find the base from B to C, we're going to write down C first, then the base B. By reduction, we get 1, 0, 0, 8, 1. And on this side is going to be 1 over 8, -1 over 8, 1 over 10, 1 over 10. That means the base, the change of base from B to C is going to be equal 1 over 8, -1 over 8, 1 over 10, 1 over 10. So that's what we got here. So we're going to type here 1 over 8, 1 over 8, and -1 over 8, and then 1 over 10, and here 1 over 10. So this is the second part. Let's check the third part. The third part of this equation, they ask you P of x with respect to the C. We already found this one, 9 over 8, 7 over 10. 9 over 8 and 7 over 10. Now we need to find the change of base from C to B. The change of base from C to B, we're going to write down B first, then C. By reduction is going to be C. Always this side is the identity matrix became, and the other side is going to be the change of base from C to B is going to be 4, 5, -4, and 5. On the last part, they ask you to find the coordinate vector with the base B, which is 8, -1. So here we're going to type 4, 5, 4, 5, and -4, -5. Sorry, 5 here. And here, 8, -1. We got it right. Let's go to the next one, example 3. So for number 3, they ask you, consider the following: A is 6, 4, 0, -1, and B is the standard base. B is the standard base, so be careful with this one. It's mean the standard base, here's the standard base, which is 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 0 on the standard base. So on C, we already have the base C. I've done everything here. The first thing they ask you to find the coordinate vector A with the respect to the base B, which is going to be C1, the first, with the base B, and C2, C3, C4. So it's going to be C1 equals 6, C2 equals 4, C3 equals 0, and C4 is going to be -1. So this is the first coordinate vector. So we're going to type here, we're going to write down as a coordinate vector. That's mean A. The vector A with the base B is going to be 6, 4, 0, -1. So we're going to type here 6, 4, 6, 4, 0, and -1. This is the first, the coordinate vector A with respect to the B. The coordinate vector A with respect to the base C, we're going to use the base C. So you're going to get the 4 equations. C2 equals 0. Convert this one to the matrix. 4, 6, 4, 0, -1. By reduction, you're going to get 1, 0, 0, 0. And here's the identity matrix. That means C1 is going to be 7 over 2, C2 0, and C3 -3, C4 is going to be 11 over 2. So the coordinate vector A with the base C is going to be 7 over 2, 7 over 2, and it's going to be 0, -3, and 11 over 2. Let's keep going on this example. To B, find the change of base to the matrix from B to C. So we need to find the change of base from B to C. So we're going to write down C first and then the matrix B. Here is the matrix C, and here is the matrix B, which is the base matrix, the standard base. So by reduction, how are you going to write down this matrix? If you look here, the easiest way to write down this matrix, each matrix here with the base C is going to be the first column, which is, if you look here, 1, 2, 0, -1, 1, 2, 0, -1, the first column. The second column is going to be 2, 1, 1, 0. The third one is going to be 1, 1, 0, 1. The fourth one is going to be 1, 0, then 0, 1. And the same thing with the matrix B. By reduction, we're going to get this matrix. This one is going to be, check this part always, the identity matrix. And this part is going to be the change of base from B to C. So we're going to type here 1 over 2 and 0, -1, -1, and here is going to be -1/2. And the second part is going to be 0, 0, 1, 0. The third part is going to be -1, 1, and 1. And here's also 1. And the last one is going to be 3/2, -1, -2, and -1/2. That's it for this part. We're going to do the same thing with C. They ask you to find the coordinate vector with respect to the base C. We already found that, which is 7/2 and 0, -3, and 11/2. Then next part is find the change of base from C to B. Always be careful here. From C to B. So from C to B, that means we're going to write down B first, then C. Here is the matrix B. This is the identity matrix. So when you do the reduction, it's going to be exactly the same. You're going to keep the identity matrix here. And this one is going to be the change of base from C to B, because here is the identity matrix. Nothing is going to change here. The change of base from C to B is going to be this matrix 1, 2, 1, 1. So we're just going to type here 1, 2, 1, and 1, 2, 1, 1, 0. The third one is going to be 0 and 1, 2 zeros. And the last one is going to be -1, 0, 1, and 1. And the coordinate vector A with respect to the base B, we already found this one, which is 6, 4, 0, -1. That's it for this example. I got it right. Let's move to the next example, the last one, number 4. Let's see how we're going to find the solution for this one. For number 4, let B and C a basis for R2 and C, where C equal, here's the base C. And the change of base from C to B, from B to C is, from B to C, here's the change of base. They're telling you let B is U1 and U2. Then we're going to find here these two, the coordinate vector U1 with respect to the base C. That means we need to find the coordinate vector U1 to the base C and the coordinate vector U2 to the base C. That's what we're doing here. The coordinate vector U1 to the base C, which is 1, -1, because here is U1 and here is U2. So U1 is going to be 1, -1, which is linear combination from the base C. So it's going to be 1 times 6, 5, plus -1, 6, 7. This is the linear combination from the base C. 6, 5, 6, and 6, 7. So 5 minus 6 is going to be -1. 6 minus 7 is going to be -1. So this is the first column in base B. Now, the coordinate vector U2 with the base C is going to be -1, 6. -1, 6. So it's going to be -1 times 5, 6 plus 6 times 6 and 7. So it's going to be -5 plus 36, which is -31, so positive 31, and -6 plus 42 is going to be 36. So this is the second column with the base B. So here in this case, we're just going to type here the coordinate vector U1 to the base C, which is -1 and -1. And the coordinate vector U2 with the base C going to be 31 and 36. And here is our base going to be -1, -1, and here is going to be 31 and 36. That's it for this example. Be careful when you type here, this is U1 to the C, which is this is vector, because this is U1 and this is U2. So we're going to type these here. And now the result here, this is going to be the base, the first column on base B, and the second column on the base B. That's it for this example.